looking at the overall outline for the chapter, we see that there's an introduction, and we at the introduction we do talk about the significance of chemistry to an esthetician, and there are significant impact on the practices of an esthetician for the esthetician to understand the chemistry and functional chemistry and the basis of that chemistry. Though we do not, as an esthetician, work on direct chemical development or chemical testing or reactions, but we are implementing the processes or the care of a client. And so the basis of that and how that impacts is needed from understanding basis of chemistry. And we're going to take a look at that more in detail when we get down to looking at the pH and the chemistry as applied to cosmetics and even chemical reactions, understanding how chemical reactions impact that. Starting with the what we're going to be taking a look at is that we start off with idea of chemistry. What is chemistry and how is that structured? Then we look at matter, and the reason why we're looking at topics of matter is because under that matter comes atoms and molecules. Atoms and molecules both are reactive elements. So atoms coming together will make molecules, and molecules do react. And then to categorize these types of atoms that we have, about 90 are in the universe. There are a lot more than that. There are quite a number of more than 90. But about 90 atoms are different types of atoms compose the whole universe. There isn't anything that does not have these atoms. In fact, everything is made up of atoms. So elements are what is a periodic elements are what categorize these atoms. And then we look at, if we're looking at these things as what a part of the matter, then we want to see what states that they stay in. And we define that as solid, liquid, and gas as well. Then we also get into looking at the physical and chemical properties of matter. Then we look at physical and chemical changes. So we are looking at properties. We're looking at properties and we're looking at changes. And then this section, though we won't be covering it in the video, does talk. It's a simple reading, but it just gives some example of common elements and the chemical compounds and physical mixtures, and does talk about some of the properties. And that's so we won't cover that in the video. It's too simple, and you can review that yourself. Potential hydrogen, we do want to cover that in depth in this part. I do want to also take a little bit overview of chemical reactions, and then chemistry as it applies to cosmetics is something that will be in the future. We do want to look at solutions. Solutions are things that we make up, and then suspensions are things that kind of hang around in those solutions. So if I have a solution and then I have a solvent and I have a solute that I put in here, now a couple of things can happen. It can get mixed in here, or it can sort of get dispersed, sort of hang around, and then begins to settle down. There are certain solutions like oil and water. When we see this oil and water and water and oil, something we're going to take a look at. And we know that the oil will separate, so you'll get oil on top and then water on the bottom. They won't intermix. So then we add surfactants to that. So we are going to add surfactants like soapy type surfactants, and they will help to allow this to emulsify is what we talk about. We say this will emulsify. So we have water in oil in water emulsions and water in oil emulsions. So these are the overview. Let's go on to the next slide. We did did a basic review, and we did talk about elements. Elements, what did they do? They define the types of atoms. Each atom has its properties, and we'll take a look at that as well. We'll do an overview of that, and then atoms will come together. Two or more atoms will make chemically will bond and will make molecules. Then, as we are talking about against matter, we do want to take a look at the states of matter, and what are they? Solid, liquid, and gas. Then we have chemical properties of matter, and physical and chemical properties of matter, and then we do have they're not just the properties, but we have changes as well. And we know that there's a physical change and chemical changes as well. And so let's continue on to the next. Today we're going to take a look at the potential hydrogen in depth as well. And we are going to take a look at the water and the pH and how pH concepts were developed from the water and the water ionization. What is ionization? Ionization is when you have a separation of the molecule into a positive electrical charge and then a negative electrical charge. So two words we want to, three words: ionization or ion. Each of these is ion. And what kind of ions we have? Cations and anions. And so cations are positive charge and anions are negative charge. So a lot of repetition going on here, but it just helps you to understand or get an overview of the terminology. And then we'll talk about acids and alkalis. Acids, and the opposite of acids is alkali. So these are the basics. And the key difference in acids in their properties, when you have acid, they feel very rough, like lemon juice are acidic, and alkalis are more like Clorox or bleach type or soapy type feeling is alkali. So just for your reference there. And then pH and skincare products is a huge topic, and then we will delve into that as well. Then testing pH in products is a little exercise that we can also do at home using litmus paper, and we'll talk about that as well. So let's. Okay. Something that in section 7.4 in the future that we will talk about is chemical reactions. Just for our reference right now, let's just get a basic idea. We will talk about acid and alkaline neutralization reactions. And the reason why we're sort of discussing it right now as well is because when we start looking at the water and pH, this concept will become important in that neutralization. We know that acids and alkalis will neutralize each other. They will move more towards the water, where the pH is 7. And then later on, we'll take a look at the chemical reactions when we get to 7.7-4 section and talk more in detail about that. Oxidation reduction is huge topic, a very, very significant topic. And the opposite of oxidation is reduction. And so when these things are happening simultaneously between two molecules, then we see that we can also call that a short terminology called redox. So oxidation here, and then red means reduction. So somebody came up with that terminology, said, hey, if these things are happening together, then let's just call it redox. And so We'll look into that. Then we have antioxidants, which prevent oxidation by neutralizing free radicals. And we see that oxidation process happening here. There's something that oxidizes, and if you look at the water or the rain water, it does have an oxygen in it. And so when it combines with oxygen, what do you get? You get rust. In a metal, you get a rust. And imagine the same type of process is happening by free radicals within our body or in our skin or even in our blood vessels. So imagine the damage that can be done by oxidation reactions that are out of control. And those out of control things happen through free radicals. Something we're going to again delve into the future at a later time. So antioxidants, what they do is they nullify the free radicals, and so that's why it's called antioxidations. So and then we have another type of reaction, which is combustion, which we know as something that is related to fire, and fire does require oxygen, and so oxygen will then also cause that oxidation reaction to happen. This is just an overview. We'll cover this more in detail in the next video, but let's move forward in today's topic. We just want to review before we get into section 7.3. We'll take a look at 7-1 and 7-2. 7-1 talks about chemistry. So what is chemistry? And this is what definition that is given. Chemistry is a science. Of course, it's a science, and that deals with certain things: composition and structure, which we'll take a look in the passing, not in something really deep or in a profound way. But something that is important to us at this point is to look at properties of the matter. And so we will, under chemistry, look at properties of matter and how matter changes under different conditions. So going back to properties of matter, we see that there are two types: physical properties of matter, and then there's chemical properties of matter. Physical properties are something we call by color, odor, weight, density. We look at specific gravity, melting points, boiling points, and hardness. So a color, of course, we can take a look at something and say, hey, that's a color. We can smell it as well. We can see its weight of the substance. And then density is based on that very weight. Density is the thickness. So something for our reference, we can say water is less dense than honey. And so that's the density. And specific gravity is based on that. So that if you take two liquids of the same volume, and let's say we did take water here, H2O, and then honey here, honey. And so we took water and we took honey. Which one of the same volume, then which one is heavier? And that heaviness within the same volume, we are comparing what? Specific gravity. Melting points is like if we have a cube of sugar and we put it on stove top or in a pan. At what temperature does it melt? And we know that it starts to melt at some point and caramelize. So melting point of different things we're looking at. Boiling point, and we always use this one because we are always heating water up. And what's the boiling point of water? What temperature does the water start to boil? And then we do look at substances and look at the hardness. So those are physical properties of water, or physical properties of matter. And then the other thing we look at is chemical properties of matter. And those are acidity, alkalinity, the reactiveness of, and those can only be measured not just by looking, but must undergo some form of measurement. And some form of reactive reactions do have to take place, and we assess their chemical properties in that way. Then something we talk about is how matter changes. So first we're looking at properties, then changes under different conditions. So if there's physical change of matter, and that's simple, that we know that there are three states of matter. We have solid, liquid, or gas. And when changes happen, a solid can turn into liquid. Liquid will turn into gas. And water is a great example of that. Ice will become liquid water, and then that liquid water will become into gas. And there is no change in that water. Water is water. Water is water when it's solid in as an ice, and when it's a liquid, it's still water, and when it is steam, it's still water. So there's no change in the water. But in the chemical properties, when we have changes in the chemical properties, that's a permanent change through chemical reactions. And so when something reacts, two molecules react, they generate a third one. And oxidation is a great example of that as well. We'll take a look at some pictures in that manner. Then the other topic that 7-1 talked about, it there's two branches of chemistry. There's organic and inorganic. Let's take a look at that. So organic chemistry is the study of substances that contain the element carbon. So three things are important: organic chemistry versus inorganic chemistry. And the first one being that there is the presence of carbon. And that second thing is that all living things, whether they are plants or animals, contain carbon. And so based on number one, that organic chemistry is the study of substances that contain the element carbon. Second thing is it is all derived from some living thing, or the term also applies to anything that has ever been alive. So even things like gasoline, plastics, or synthetic fibers, pesticides, fertilizers are all organic substances because they've been derived from living materials at some point. They've been either through compression, we get plants and animals and things that have been compressed for a long time will generate gasoline. And plastics and synthetic fibers are generated from plants and trees. Pesticides are generated from animals themselves, and as well as fertilizers. So all these have heavy-duty carbon base to it, and so all that is related. So that's where the living things are important. Then the last thing is, because this carbon is present in here, carbon is very flammable, and carbon will react with oxygen and will generate heat. And so the flammability is the third important significant aspect to this. In organic chemistry, in contrast to organic, do not contain the element carbon, but there's a little bit of a qualification. It says, but may contain the element hydrogen. And the reason why they say this is because wherever there's carbon, you have a lot of hydrogen. And so that distinction is made in that sense that, okay, you can have though you don't have carbon, you can have hydrogen. And so just a little bit of a distinction. Don't base too much emphasis on this one, stay with the idea of carbon, whether carbon is there or not there. If it's there, it's organic chemistry, and if it's not there, then it's inorganic chemistry. And then based on that, because the lack of carbon, inorganic substances are not flammable and will not burn because they do not contain what? Carbon. And inorganic substances are not and never were alive. So nothing, this is not derived from living materials in any way. And these examples are metals, minerals, glass. So like minerals mean a lot of salts, glass, pure water, air are examples of inorganic substances.